factoring special products. Alright, so a little review. Remember from last chapter, a perfect square trinomial is one that is made from squaring the same binomial. Alright, so in this case we have a square and the side lengths are a plus b. So our area for this square is going to be a plus b times a plus b, or a plus b squared. Okay, that has the result of giving us an a squared, 2ab plus a b squared. Okay, or this form right here, a squared plus 2ab plus b squared. Okay, if we had a negative value for b, it would be a squared minus 2ab plus b squared. Okay, but same form. All right. So now we're going to look at recognizing and factoring these perfect square trinomials. If we are trying to figure out if a trinomial is a perfect square, the first thing we're going to do is look at the first term and the last term. Okay? If this is a perfect square and this is a perfect square, then this trinomial might be a perfect square. If either of these is not a perfect square, then this is not a perfect square trinomial. Okay? So if we look at this, 9x squared, I could factor that into 3x times 3x, so that is a perfect square. And 16 factors into 4 and 4. Okay, so that's a perfect square, so this might be a perfect square trinomial. And now we're going to look to see if the middle term is the same as 2 times one of the roots of each of these. Okay, so I'm looking to see if this middle term is 2ab, or in this case 2 times 3x times 4. 3x times 4 is 12x, times 2 is 24x, so it works. This is a perfect square trinomial. Okay, let's look at some other ones. Alright, this one, 36 is a perfect square, 2x squared is not. Alright, so 2 is not a perfect square. There aren't two integers that when you multiply them by each other equal 2. So this is not a perfect square trinomial. I don't even have to worry about looking at the middle term. Okay, next one. So 4 is a perfect square. Its root is 2. 25x squared is a perfect square. Its root is 5x. Okay, so now I'm looking to see if 5x times 2 times another 2 equals 20x. Okay, and you can see I'm pretty much ignoring this negative sign. Right? The fact that I have a negative sign there means that in my binomial, okay, I have a negative sign in the middle. It's going to be a negative times another negative. All right? That'll give me a positive last term and a negative middle term. Okay? But I don't have to worry about that. All right? Because that would just mean that, well, a factor of 4 is actually the negative 2, and that's fine. Okay, that works. We don't even have to worry about that when we are factoring this until the end, when we get to the point where we're saying what the binomials of this would be. Okay? All right, so back to it. So we've got our 5x and our negative 2, so, or just 2, 5x times 2 times this 2, that is 10x times 2 is 20x, so this is a perfect square trinomial, and my factors would be 5x and negative 2. So it would basically be 5x minus 2 and 5x minus 2, or 5x minus 2 squared. Okay, all right, let's keep going. Okay, so this one, this one's got actually a lot of things wrong with it. So first of all, 6 is not a perfect square. Okay. 24, well, this doesn't even have an x on it. And then 4x cubed, anytime you have an odd exponent, okay, there's no way that this could be the result of the same number squared, right? Because if I'm multiplying x times x, I get x squared. If I'm multiplying x squared times x squared, I get x to the fourth. But there's no way I could ever get an odd exponent. Okay, so if you ever see one of those, you know automatically it's not a perfect square. Okay, let's look at this one. X to the fourth. So like we just said, even powers can be squared, and it doesn't have a number by it, so this could be the result of x squared. Okay, and 25 is going to be 5 times 5. So this is going to be x squared times 5 times 2, which would be 10x squared, and that works. Okay, so this would be a perfect square trinomial with x squared plus 5 as its binomial. Okay, do we have any more? Nope, that's it.